Hey everyone, welcome back to Roboarmy. Today we are building something super cool, unique and exciting. A smart Arduino-based mini treadmill control system. This project is not just a simple motor control project. Here we are creating a complete smart treadmill style control interface using push button, servo motor, DC motor speed control, and a live OLED display dashboard. Using the buttons, we can control the treadmill speed in real time, while the OLED display continuously shows the current speed percentage and servo angle like a real smart machine interface. And the best part, we are also using PWM-based smooth motor control and special Kickstart logic for better load speed performance. So without wasting any time, let's start building our smart mini treadmill system. Here are the components required for this project. Arduino Nano 80 Mega 328, OLED display module SSD 1306, servo motor, DC motor, A298N motor driver, 4 push buttons, breadboard, jumper wire, double cell battery holder, lithium ion battery, USB cable. Now let's start with the connections. First place Arduino Nano 80 Mega 328 breadboard properly on your workspace. Now connect the Arduino power pins to the breadboard rails. Arduino 5V pin, breadboard positive rail, Arduino GND pin, breadboard negative rail. Now connect the OLED display module. OLED VCC pin to breadboard positive rail, OLED GND pin to breadboard negative rail, OLED ACL pin to A5 pin of Arduino, OLED SDA pin to A4 pin of Arduino. Now let's connect the servo motor. Servo signal pin to pin 9 of Arduino, servo VCC to breadboard positive rail, servo GND to breadboard negative rail. Next we will connect the push button. Button 1 to pin 2, button 2 to pin 3, button 3 to pin 4, button 4 to pin 5. Now connect the other side of all push button to the breadboard negative rail because we are using input underscore pull up mode in the Arduino code. Now let's connect the L298N Motor Driver module. ENA pin to pin 11 of Arduino, in 1 pin to pin 8 of Arduino, in 2 pin to pin 7 of Arduino. Now connect the power pins of L298N GND pin to breadboard negative rail, L298N 5V pin to breadboard positive rail. Now connect the DC motor. Motor wire 1 to out 1 of L298N, motor 2 to out 2 of L298N. Now if you are using an external battery or power supply, battery positive connect to 12V pin of L298N, battery negative to breadboard negative rail. And very importantly, connect Arduino GND with the L298N GND terminal so all grounds become common. Next, open Arduino IDE and upload the code. Now let's understand how this smart treadmill system works. First, we include all the required libraries, wire.h, adafruit underscore gfx.h, adafruit underscore ssd1306.h, and servo.h. Now, these libraries helps us control the OLED display and servo motor easily. Now, next we define all the pins for button, servo motor, motor driver, and OLED display. Then we initialize the OLED display and create the servo object. Now comes the button control logic. When button 1 is pressed, the servo rotates clockwise. When servo angle increases step by step until it reaches 180 degrees. When button 2 is pressed, the servo rotates anti-clockwise and the angle decreases step by step until it reaches 0 degree. Now let's talk about the treadmill motor speed control. Button 3 increases the motor speed, button 4 decreases the motor speed. Now instead of directly using random PWM value, this project uses predefined speed level for smoother and more stable motor control. The speed levels are 0%, 20%, 40%, 60%, 80%, and 100%. Now, using PWM signals, Arduino controls the motor speed through the ENA pin of L298N motor driver. Now comes one of the coolest part of this project, the kickstart logic. Sometimes DC motors cannot start properly at low PWM speeds because of motor friction. Now let's talk about the OLED dashboard. The OLED display continuously shows current servo angle and current treadmill speed percentage. Whenever any button is pressed, the display updates instantly in real time. This gives the project a smart, modern, machine-like interface. Now connect the Arduino UNO to your computer using a USB cable. Open Arduino IDE, select Arduino UNO board and correct COM port. Then upload the code. After uploading, power the circuit properly. Now test the project. Press button 1 and servo rotate clockwise. Press button 2 and the servo rotates anti-clockwise. Press button 3 and the treadmill motor speed increases. Press button 4 and the treadmill motor speed decreases. At the same time, the OLED display shows all live update instantly. This project helps students learn Arduino programming, PWM speed control, servo motor interfacing, OLED display graphics, motor driver control, button debouncing, and real-time embedded system design. It's a super fun and practical beginner to intermediate Arduino project for students, makers, and robotics enthusiasts. And that's it. Our smart Arduino-based mini treadmill control system is ready. If you want more amazing robotics and Arduino project, make sure to subscribe to Roboarmy. Thanks for watching.
Roboarmy. One-stop global community for teens in robotics and AI.